believe your quiz. All right, let's resume this recording, and that way you guys can watch this again later if you want to. All right, so number one, Matthias was laughing, but it's important to know, part A, what distribution do you have? It is normal. How do you know? It says right there. So not that we're going to ask you that question on the quiz, but I do want you guys to know that, yes, it should tell you it is normal. All right, so be aware of that. I wrote over here my little format like this just to remind you guys it's in, and then there's my average, and there's my standard deviation. If you wrote it out with the little symbols, there it is right there. Letter C, what's the probability that Violet screams for more than 90 seconds? So we got to write our probability statement that X is greater than 90, and we get the answer of 0.1495. We okay with this one? All right, if you didn't get this one, when you type it into your calculator, you have to use option number 2 because you're looking for the probability, and it's going to ask you for an upper or lower limit. This is your lower limit because every number is going to be greater than this, and then your upper limit is infinity, just in case you got stuck. So if you want to write on there, hey, this is an example of doing number 2, put the number there to help you remember. What's the probability that Violet's scream length is within 30 seconds of the mean? So you've got your mean, you've got your standard deviation information. So you just take 30 away from your average, so you get 38.4 and 98.4. This one's actually easier than it looks. You're still doing option number 2, but this becomes your lower, and that becomes your upper limit. We okay with these? Because I think out of our 3 distributions that we're going to have on our quiz Monday, the normal one tends to be the most complicated, in my opinion. I could be wrong, but that's just my opinion. Because you got all the weird calculator stuff you got to do with this one. Can you do what, sorry, Lauren? You want to see what it looks like in the calculator? So normal CDF, because I need option 2, because I'm looking for a probability, right? So I'm going to put 38.4 and 98.4. And then my average is 68.4. Oh, C, I'm sorry. All right, so for C, then 90 is my lower limit. Upper limit is 1, E99, and then 20.8 goes there. You got them flipped? Oh, okay. Another thing to remember with the continuous, you don't have to worry about including or not including the number. That's not a problem with the continuous distributions. So if it tells you more than 90, put in 90 into the calculator. There's not going to make any difference if you include 90 or not on continuous. So don't sit there and try to be like, is this the same as like 90 point? How many zeros do I put, Mr. G, so I don't include it? Don't worry about it. Just put in 90. The calculator knows it's smart. Okay, so that covers that one. And then last one, the middle 75%. So in my calculator, I'm going to use option 3 on this one because I want to know an X value or X values. And so the area needs to be 0.75. Don't type it in as an actual percentage. It'll cuss at you. And then I just wrote it like this. A lot of the answer keys, Ms. Nichols says, is this, between this and this or something. Just, make sure you organize them. It makes no sense. I will say this. It makes no sense to do the biggest one and the smallest one because we're going from left to right. And then your label goes afterwards. These are seconds. So this is normal CDF. And this is the inverse norm if you're looking at your calculator, because they may not be the same numbers in yours. All right, we okay with the normal stuff? What you got there, Gage? E? You betcha, bud. So do you have one of these or are you using a different calculator? You're using this one. Oh, perfect. So you go second vars and then option 3 because we're looking for an X value, not a percentage. And then for your area, type it in as a decimal, so 0.75. Standard deviation still 68.4 and 20.8. I'm going to do center because I want the middle, 75%. So once I got that all squared away, press enter a few times, and there's my 2 numbers. Right there. So you're going to get two separate answers inside that group of brackets.
Oh, that's pretty good. 우리는 지금 H맛 가고 있어요. 우리는 지금 H맛 아니. 가고 있어요. Let's start the basic.
There we go. She keeps talking. Okay, we good? All right. Next up, Violet and Patty often play her favorite game, Candyland. When Patty comes to babysit, the distribution for the X amount of times they play when they babysit is described in the table below. There it is. 0.25 is your missing number. You guys are pretty good at figuring that out, so I'm not too worried. And then for From here, what type of distribution? Just a basic old discrete, boring distribution. X only has certain counts for variables is the reason what told me this. You guys can write whatever. All right, the reason why is more for you than for me. I'm not grading your reason why, just as long as you know. It's just a basic old discrete distribution. Not binomial, not geometric, there's nothing there. So what's the mean and standard deviation? So you have to show your steps. But you can find the answer from, if you guys remember, the list. So if I go into stat, edit, I can type in all of my X's and all of my percentages in my list. And then go stat, calc. You can do 1 or 2 var stats. It doesn't matter. We figured that out the other day in tutoring. I use 2 var, but you can use 1 the same. And just make sure your frequently list says L2. And then right there's my average. That's the X bar. And my standard deviation is that right there. But what's required as far as work on like an AP exam, you do have to write out that you would do all of this to get your average. Standard deviation, they don't give a flip. You can just say, there it is. Because the standard deviation one would take you like 2 times the amount of writing than this one, because you got to do the variance and square it. And yeah. Kate really enjoyed that. So maybe. All right, probability that Patty and Violet will play more than 2 games. So probability that X is greater than 2, which is the same as probability that X is greater than or equal to 3. Either one of these formats is fine. They're both the same. So you get 0.63 because I'm basically going to add this plus this plus this plus this. Or 1 minus the ones I don't want. Either way is fine. You cool with that? All right, next up, letter D. What's the probability Patty and Violet will not play 4 or 5 games? Lots of different ways you can approach this one. I just said probability that X is less than or equal to 3 plus the probability that X is greater than or equal to 6. But basically, what are you doing? This one, this one, this one, and this one, plus this one. I don't know. Maybe, you know, the babysitter's like, I'll play 6, but darn it, don't make me play 4. I don't know. It's just a way to test to see if you know how to add things up. All right, we good? Questions? All right, that takes care of the just basic old discrete stuff. Next up, number 3. When Violet is crying, Patty randomly selects stuffed animals to give her to try and make her stop crying. She continues to hand Violet stuffed animals until she stops crying. Each stuffed animal has a 64% chance getting her to stop. So our distribution type is geometric. How do we know that it is geometric? Help us out there, Ms. Kate. How did you know? Yes, exactly right. There is no set limit of trials. You said the exact phrase I was looking for. We're just seeking that first success whenever it may come. All right. If it was binomial, it would say given 30 tries or something like that, which the other one says later on the worksheet. So seeking that first success, those are the types of questions we're going to be answering. So here's our standard deviation and average formulas. So 1 divided by the percentage takes care of your average, and 1 minus your average, or I'm sorry, 1 minus your percentage, square root it, divided by your percentage gives you the standard deviation. Okay there? All right, just use those formulas. And then for letter C, probability that Violet stops crying when she gets the 4th stuffed animal. So we want to know the chance the success happens on number 4. So that's equal to 4, not less than or anything before it, just exactly number 4. So 0.0299. The next one, probability Violet does not stop crying until after the 4th, is the same as saying it takes at least 5 or more times to get her to be happy, which is 1 minus less than that. This is still discrete, so you got to flip the numbers and not overlap stuff. If for whatever reason you need to adjust your percentage, maybe it says, what's the probability Violet stops crying, you know, something that you can change your percentage if you need to. Yep.
I put down the probability of X is greater than 4.
That's fine. You just have to make sure when you type it in the calculator that when you say X is greater than 4, you're including 5 or bigger.
Oh, because I did 1 minus and then I got it wrong.
Well, you probably put 3, right? Yeah. So when you write it like this, and that your statement was fine, you could write it like this. That's fine. But when you write it like this, that's equal to this one. So when you look at a number line, you got 0, 1, 2, 3, 4, 5, etc. When you say greater than 4, you start counting at 5. So when you want to do 1 minus, you got to minus the first number you stop counting at, which in this case is 4.
So it's just harder to do.
It's easier to remember it that way, in my opinion. But like I said, you can write, I know Danielle's the one that came up to me and said, can I write it like this? Yeah, that's fine. Like, we're not going to take off points because these both mean the same thing on a discrete distribution. If it's continuous, no, those do not mean the same thing. Those are completely different ranges or intervals. Good question, though. I like it. Any other questions on the geometric? We okay with these? So we're seeking our first success, not how many successes, just the first one. Daniel, you got everything you need? Okay. You're leaning over like you're writing, so I don't want to take it away. You need me to scoot it up? Okay. Half asleep. All right, number 4 on the back. Violet loves to color, so Patty often uses coloring stuff to entertain her, which has the added bonus of keeping her from screaming. Yay. All right, Violet isn't the most artistic child, though, so her coloring is usually just drawing lines. The length of the lines are evenly distributed. So what kind of distribution do we have? Uniform, continuous distribution. How do I know? Because it's even. It has a maximum length of 12.5. So I often, to the side of these rectangles, write out my A and B. You don't have to do this. This is Mr. Jennings' PTSD from physics days when they always gave you like certain things and then you had to go find the missing things. I just wrote out what I have. So I have a B value of 12.5 because that's the maximum length. A range of 9.6. So subtract that from 12.5. That gives me A. So now I don't really need to draw the rectangle. I know the two extremes. That's just me. If it helps to draw your rectangle, draw it. You're not going to see it on my thing. I also automatically know that the height is 1 over the range. So 1 over 9.6 is going to be the height for this whole thing because we already did the algebra and explained how that works. If you need to see it again, just let me know. So part B, what's the mean and standard deviation? A plus B divided by 2, B minus A divided by square root of 12. So 7.7, 2.7713. Don't forget your labels again on averages and standard deviation. So this is inches. Now, everything is a rectangle. So once you figure out how far away the X is that you're trying to figure out from one of the sides or whatever, then you have the length and you already have the height and you just multiply. So for letter C, what's the probability her next line will be longer than 7.5? Well, the distance between this and this is 5. The height, again, is always this number, and then multiply them, there's 9. So again, for me, the rectangle just takes extra time. I'm lazy. So you don't have to draw the rectangle if you understand kind of what's going on with all the numbers. But if it helps because you're visual, then draw it. For whatever reason, I just don't waste my energy doing it because for whatever reason, I got it. But if you don't, then you don't have to be awesome and skip it. You can draw a rectangle. All right, what is probability Violet's next line will be no more than 2.5 inches long? Trick question, 0. Because what's the minimum amount that we're allowed in this distribution? 2.9. There will probably be one of those questions on the quiz. So just watch for it. All right, that's it for number 4, uniform with the rectangles. We okay with this? Questions, comments, concerns, complaints, hatred? Okay. Violet's favorite snack is goldfish. There's a bunch of information there saying that she brings her goldfish. We know it's binomial. How? There are fixed trials and percentages. So both qualifications have been met. They're going to do it 30 times, 30 goldfish, with an 11% rate of dropping any one of them on the floor. So this is different than geometric because I'm not looking for success. The first success, I'm looking for total successes. So what is the mean and standard deviation for these? N times P gives me 3.3 goldfish. Standard deviation gives me 1.1738 goldfish. All right, probability that the amount of goldfish Violet drops is within 1 standard deviation of the mean. So this was the mean question on the homework and quiz that we didn't like. So you have to be careful when you do these and make sure you get things matched up in the right discrete setting. So start by just doing simple subtraction and addition. So 3.3 plus or minus this number gets you these two. I think everybody's good there. Next step is to make sure that your discrete numbers fit inside this range here. So I can only fit between 2 and 5 inside these numbers. If you've been playing on Xbox or whatever at home and not paying attention for the last 2 weeks and you just rounded because you're a good little math student, you still got lucky today and got them both right. But that's not always going to be the case. Okay, so if you're like, well, I just rounded to the closest whole number, Mr. G, got it. Yeah, this time that worked. But as we saw on the quiz, this could be next time 1.0061 or something, and you're going to round to 1, and you're wrong because 1 is outside the range of these two numbers. So here's the actual distribution I care about now. Where you have to be careful is I want to include 2. So when I go to do my subtraction, I really need to do it in the calculator as probability of x is less than or equal to 5 minus the probability that x is less than or equal to 1. Because if
Wait,
I
Mr. G.
what's up, Matthias?
All right, never mind. You can finish explaining what you're.
Okay, if I put a 2 here, then I'm taking the 2 away from my range because I don't want to subtract the 2. And again, think of it as a number line. It goes all the way to 30. I'm not going to draw the numbers since we're down here at this part of it. All right, but you got 0, 1, 2, 3, 4, 5, 6, 7, 8, etc., all the way to 30. All right, I want the distribution to include 2 all the way to 5. So if I do the probability that x is less than or equal to 5, what I've done is taken all, or 1 minus, I'm sorry, not 1 minus, I'm sorry, just the straight bin. Mr. G's confusing himself. Just this. What I'm doing is I'm only concerning myself with these numbers. All of these have been canceled out because I don't want them. If I accidentally do 2, then what happens is I now subtract that from this and the 2 gets canceled out, but I want the 2. So instead, I need to make this a 1 so that I only take away the 1 and keep the 2 inside of the ring. That's why it works that way. So there's 2 things that can trick you up on this: doing these numbers wrong to here and not moving the numbers correctly here. So just watch for it. There's 2 tricks on it. Matthias, did I answer your question, or was that what you're going to add to it, or what?
Oh no, I had a question on part B.
B. Okay.
So for the standard deviation, what would the actual numbers be under the
30.11 and 0.89.
Oh, wait, how did I get that wrong? Okay, never mind then. I think I put in the wrong numbers then.
Right? Because isn't 0.89 the opposite of 0.11?
Yeah. Okay, I just got confused.
Hey, yesterday I couldn't figure out a simple problem, so it's possible that I screwed up. So I trust your instincts, sir. If something looks wrong, say it. Yes. I think it'd be helpful to show this way. If something accidentally happens, they understand you kind of do the process. So I know it's a little weird, but just like you can round it to 4 numbers. But I would write it down just for your, like, hey, I knew what I was doing, but I maybe like you get in a hurry or don't. It happens. And you put a wrong number here, you're covered. They'll know you knew what you're going to make. Okay. All right. Letter D, probability that the amount of goldfish Violet drops is at least 6. So I want the probability of 6 or more goldfish. Can't do that in the calculator, so we outsmart it and we go 1 minus what we don't want. All right, so this is binomial. Probably the hardest of the discrete stuff we did. Questions in. Sir.
So on C, how can you go from the probability that 2 is less than or equal to the probability that you change it to 1?
So again, look at this number line here.
Yeah, I still don't really.
So I want these numbers. I want my range to be 2, 3, 4, or 5.
Yeah.
Those are the only numbers I'm going to accept based on my stuff in here. So it has to be either 2, 3, 4, or 5. So if I do 1 minus the probability and I take a 2 away, then I'm going to remove that because I'm subtracting, right? These are being subtracted. So if this is a 2, then I'm taking the 2 away, and therefore I'm missing 1. I now only have 3, 4, and 5 when I need 2, 3, 4, and 5. So I don't want to subtract the 2's percentage from the little range there. Does that make sense?
Since you're subtracting, you would take out 1 from
Yeah.
Okay.
Now, here's another way to look at this. Let's say that this right here just confuses the ever-living whatever at you. Like you're just like, I cannot get around my brain, Mr. G, how to do that. No big deal. Are you okay with the fact that you need a 2, a 3, a 4, and a 5 as your numbers? Like, does this at least make sense? So if this makes sense, but this part doesn't, then you can, it's going to be a little more tedious, but it'll still give you the same answer. You can do x equals 2 plus x equals 3 plus x equals 4 plus x equals 5. You can just go ahead and find all 4 of those and add them up. You'll get the same answer. If for whatever reason you're like, I just don't trust that I'm going to understand what's going on here, then don't stress it. Just do it this way. It'll take you an extra 30 seconds, but you'll know you get the right answer. So, and that might help for you, Jackson, to see that because we want to make sure we include the 2, the 3, the 4, the 5. Each of them has percentages underneath. Does that help out there? Okay, so think of it like almost one of these problems, and once you figure out which numbers you want, just add up the percentages you need on this. That might help you out. That way you're not sitting there trying to get your brain too confused, because maybe it's hard for you to see kind of how it's taken away. And that'd be perfectly fine. That's another way to do it. All right, any other questions on the number 5 before we move on to the last one? All right, last one's all the crazy stuff. I'm just going to load it up here at once. I will explain E. I know it was a tough one. All right, number 6, we got this weird little distribution. How do I know it's an unusual continuous? Because it just got weird shapes. That's why it falls under that one. So what's the median for this distribution? The median is where the area is split 50-50. So I need to kind of add up all of my different shapes and see, where's a good halfway point between half the areas on the left and half the areas on the right. Mr. G's done a lot of these, so I just instinctively went for the 0.75 because it just eyeball testing for my years in geometry and all this probability stuff I've done. It looked like it was right there. So I got lucky. My first try was exactly in the middle. You may not be able to see that. You might try like 0.5 because your brain's like, well, that's halfway. It's fine. What you need to do, though, to make sure that you're at the median is figure out all the little individual areas and make sure they add up to 50% on either side of that location. So I did the big triangle first, which has a base of 0.25. I don't know who this person is who keeps calling me, but they haven't given up all day. All right, so you find that the base here is 0.25. The height is 4. And then divide that by 2 or times 1/2 or however you like to do it. And I get 0.5 as my final answer. So my brain automatically went, oh, if 50% of the area of this whole thing is here, guess what? The other 50% is here. So I found the right spot. So I moved on from that question. I went ahead and figured these out anyways because I needed to for some other things. But it confirmed that I have a 50-50 split at this point. Does that kind of make sense? We didn't really go over one of these on the notes, so I want to stop and make sure you guys are okay with this. Okay. For these, you just kind of have to play with these unusual ones. It could be a grab bag of whatever. We don't know what kind of shapes and weird stuff we're going to get. So just kind of start combining and subtracting until you get to where you want. So between 0.15 and 0.75 is like this little spot here, all the way to this spot here. So it's not one shape. It's like 2 different shapes. So I've got this little triangle that I already know is 0.25. So I just added that in there. Plus, the distance between 0.15 and 0.25 is 0.1. So there's my base. And then the height of that little rectangle there is 1. So I multiply those, add that to this, and there's my answer of 0.25. Again, this is just Mr. G being his weird geometry self and kind of putting shapes in. If you guys hated geometry, this might take a little bit more practice or just thinking about it or going slower. Save these for the end. Now, just like on the other one, you cannot do equals to anything. So what is the probability x equals 0.25? It doesn't exist, 0. It's continuous. Nice try, Mr. G. Don't get me on that one. So probably likely that you're going to see one of those too. So just be ready. Not every answer is going to be a number. All right, letter E. What do we do here? So with letter E, there's a couple different ways to attack this one. I need basically all of the area from 0.9 backwards. So for me, it was easiest to figure out this little trapezoid that's kind of hiding here. I redrew it over here so you can see it and subtract it from 1. And then everything left was covered. If you don't want to do all this weird trapezoidal formula stuff, then you got a rectangle, a triangle, and then a smaller triangle. You can do it that way. You can just add up all 3 shapes. You'll get the same answer. So the real question is, how do I find what this height is here? Because it's not a nice halfway, like you said, Mr. G, between these two, so I can't halfway this one. No, it's not halfway, but what I kind of figured out is the rate of change between 0.75 to 1 is 4. So when the graph moves this much, the height went up basically that much. So I just kind of did in my brain a little bit of division and said, okay, well, if I got to go up, what's kind of happening here? Oops, did the wrong way, sorry. So each point is kind of doing this. And so I kind of played with it and said, okay, what is, 4 minus that answer? Just it's not perfect, but I kind of played things around. And I figured out this height is 2.4. Some people set it up as this little, similar triangles, crosses. There's lots of different ways to do it. Okay? But the rate of change on this is consistent. So if you can figure out that you're a certain range over, okay, so I was, at 0.9, I'm going to be this far over. That's my range. And so if I can just figure out, like, okay, how much is that compared to, So 0.25 goes to 4, then 0.15, that's what I should write there, goes that way. So that should give you kind of the same answer. So times 4 divided by 0.25. Yep, there it is. I just didn't have my last 5 on it. So sorry, it should be 0.15 on it. So this is the easiest way to do it. If you remember how to do similar triangles, you can set up a proportion and you can cross multiply. That to me is the easiest way to do it, but other people got fun ways they like to do it. Go for it. So once you figure out that height, I've got base 1 plus base 2, so 2.4 plus 4, times the height, which is 0.1, that's that little distance right there, times 1/2, and then minus that from 1.68 my final answer. Lots of work. You might get maybe one of those types of questions, maybe. I haven't looked at the quiz enough to know if even that's on there. So that's it, guys. Questions for me? Hopefully okay, not too bad. We didn't have to re-erase hopefully everything. I'm not at home looking at you guys, so I don't know. All right, so quiz will be on Monday. It'll be continuous distributions. If you guys have some last minute questions over the homework, we can do that at the beginning. The quiz will pretty much take the class, and then you'll have the rest of the time to work on FRQs and such. So I'll pass those out to people on Monday. I'll also publish the answer key for this and my video so that you guys can go back